This is section 4.5, sum of the year's digits method. So this is the final method of depreciation that we're going to be talking about. So what happens is the years of the asset's lifetime are labeled 1, 2, 3, so on and so forth until you've gone through all of the years. And the depreciation amounts are based on a series of fractions that have the sum of the year's digits as their common denominator. The greatest digit is assigned to a year is used as the numerator for the first year, the next for the second year, and so forth. So let's see what that looks like. So the cost of a machine is $17,000, its salvage value is $2,000, and the estimated life is 5 years. So the depreciable amount is $15,000 from that $17,000 minus $2,000. So 5 years, we label them 1, 2, 3, 4, and 5. And we calculate the sum of the year's digits by adding the digits assigned. So 1 plus 2 plus 3 plus 4 plus 5 gives us 15. And then we put that into a series of fractions. So we have 1 15th, 2 15th, 3 15ths, 4 15ths, 5 15ths. And then we take the fractions in reverse order as the depreciation rates. So it depreciates faster at the beginning and slower at the end. So for year 1, our fraction is 5 15ths. Multiply that by the $15,000 to get that it depreciates $5,000 in the first year. Year 2 is the 4 15ths times the depreciable amount, which is $15,000 still, and we get $4,000, and that goes on and on and on until you've reached the end of its lifetime. So for this one with 5 years, it was really easy to do 1 plus 2 plus 3 plus 4 plus 5. But when you get into things that have a longer life, then you can use this formula to figure out the sum of the year's digits, okay, where n is the life expectancy. So the life expectancy of a piece of equipment is estimated to be 30 years. What is the sum of the year's digits? So our sum is equal to n is 30 times 30 plus 1, which is 31, over 2. Okay, that becomes 930 divided by 2, which is 465. So 465 would be the denominator for all of our fractions. All right, let's look at what a depreciation schedule would look like with this method. So using the sum of the year's digits method, prepare a depreciation schedule for a pizza oven that was purchased for $3,000 and has an estimated useful life of 5 years and a salvage value of $900. So I started the table for us. So the first thing we need to figure out is what the depreciable amount is. So we take the cost minus the salvage. So we take 3,000 minus 900 to get 2,100. That's the depreciable amount for all the years. So I'm just going to write that down, this entire column. Then we need to figure out our depreciation fraction, which starts with finding the sum of the year's digits. So it's 5 years. So 5 times 6 over 2 is 30 over 2, which is 15, which we know because we already did that. So all of these fractions are going to be out of 15 over 15. And then to assign the numerator, we're just going to write the numbers in reverse order. So starting from the bottom would be 1, 2, 3, 4, and 5. So to find the amount of depreciation, okay, for year 1, we're going to take 5 15ths times 2,100 to get 700. So it depreciated $700 in the first year. So the accumulated depreciation, since it's only the first year, is just $700. And our book value at the end of the year is the 3,000 original minus the depreciation, so 2,300. And then we continue that process going forward. So we have 4 15ths times 2,100. That's going to be $560. So the total accumulated depreciation is 700 plus 560, which is 1,260, making our new book value 1,740. And then you can keep going in the process. I'm just going to fill this in for you just to save a little bit of time. So accumulated depreciation, remember the 420 plus 1,260 gives us 1,680. And notice eventually at the end, our accumulated depreciation should be equal to our depreciable amount. And our book value is the same as our salvage value at the end. So let me finish putting this table together. So in the end, we should have 900. Notice this number over here, this 2,100 should be the same number that pops up in that depreciable amount column.